and today we are going to look at the LCD driver module for the RC2014 range of Z80 retro computers. There are three options with this kit. You can have a 2 rows by 8 characters display, a 2 row by 16 character display, and finally you have the option of going for a 4 row by 20 character display. In today's video, I'll be doing the 2 by 16 display. As you can see, there are not a great many components in this kit, and completing it will not take you long. However, take your time, as any errors you make during the build can take a while to debug once the board is assembled. The LCD display is fully assembled and merely needs an edge connector soldered on to allow it to connect to the main board. As always, I'm going to start with the low-profile components first. In this project, you will only need a soldering iron and some wire snips. So first, the single resistor and the 3 capacitors. All the components are marked on the circuit board, so assembly is quite straightforward. Something to hold your circuit board while you are soldering is indeed an advantage. Be careful when snipping off the long excess wires from the resistors and capacitors, as these wires do conduct and having them lodged somewhere on the circuit board is not good. It's always good to do a visual inspection periodically to ensure that you haven't either missed a solder joint or have inadvertently soldered two things together that shouldn't be. There are 2 potentiometers on the board, which are 3-terminal resistors with a rotating contact that forms an adjustable voltage divider. These are used to control the contrast and backlight brightness of the LCD display. Next, we can solder in the integrated circuit chip sockets, taking care to align them with the markings on the board. To ensure that these are soldered in level, I usually hold them down with an elastic band and just solder the corner pins first to ensure that the socket is level. Once you are happy that the sockets are in place, you can then solder in the remaining pins. There is an edge connector socket at the top of the board to allow the display to be plugged in. Having a socket for this is ideal should you later decide to replace the LCD display. We can now solder the remaining pins on the chip sockets and solder the edge connector that will allow this board to be added to one of our RC2014 computers. Once that is complete, after a visual inspection, we are ready to add the edge connector that our LCD display will be plugged into. Once that is soldered upright into place, we can then solder the edge connector to the LCD display. This is the only addition you need make to the LCD board itself. Just a 3-pin header to solder, and we will be ready to populate the IC sockets. Taking care to check the markings on each IC against the board, we can then carefully bend the IC pins into place and fit each integrated circuit chip into its respective socket. Now we are ready to mount the 2 boards together. A nylon standoff is supplied to ensure that the LCD board is securely fixed. There is still a jumper to put into place, but I'll need to check the documentation for that. Next, we can connect this new board to one of the RC2014 computers and try it out. And here we are, having added this LCD board to an RC2014 Micro Plus computer. One thing that I'd missed when building this LCD board was the jumper header to set the port that it uses. But now that it is fitted, we are ready to go. I'm running this RC2014 computer off a power bank battery, which provides more than enough power for the whole system. If we power on, you can see the display illuminate. So if we go into Basic and we'll try to send some text to the display. There is some test code we can borrow to try this display out. Just copying the code and we'll paste this into TerraTerm to load it into the RC2014. And there is the code loading. We're using two variables, one for the register and one for the data port. The register is used to control the LCD and the data port is for any text we need to send to it. So let's bring the camera back up to display the computer and run this application. We'll put some text in and see how it displays. And there we have the text displaying on the LCD panel. The backlight and contrast make it a very clear display. So let's run it again and give it a longer string this time. So obviously there is no wraparound to the second row. Once 16 characters have been displayed, that's it. So how can we access this second row? Looking at the PDF from Hitachi, we can determine the code we need to send. So we'll amend our code to test for the 16th character having been printed on the LCD. So uploading a new version of our program in which we have added an extra line of code to test for the 16th character, and to output the value 192 in ASCII to the register on the LCD board. So let's try running this amended code now and see if it handles longer strings. And there we have our code, now accessing both lines of the LCD display. It's worth noting that even if we reset the computer, the LCD display continues to display the last message it was sent. This message only disappears if the computer is switched off or the clear display command is given. This LCD display, links in the description below, is both easy to assemble and inexpensive, and gives you another mechanism to provide feedback from your RC2014 Z80 retro system. That's it for today. Thank you for watching.